if we have a quadratic function and we're wanting to know something about a maximum or minimum value of that particular function, well, it turns out here's what we can consider. Let's say we've got f of x equals 2x squared plus 8x minus 7. F of x equals 2x squared plus 8x minus 7. So the question here is or let's say it this way. Does the function, does f have a minimum or maximum value? Does f have a minimum or maximum value? All right, so the reason this question comes up is because of the very shape of the graph. Again, this is an x squared equation, and so what shape does that have? Parabola, okay? And in this case, it's a parabola that opens which way? Opens up. And we know that because the a value here is 2, which is positive. So an a that's greater than 0, that'll be an opening up parabola. Okay? Now just real quick, graph-wise, I believe it's going to look something like this, just real quick. I believe it's going to look something like that. But to answer the question, does it have a minimum or maximum value? You don't really have to graph it, but let's just think about the graph. All right? So with that parabola opening up, and I think it's going to be down here somewhere. It opens up, that's for sure, wherever it is. So the question is, does f have a minimum or maximum value? Well, looking at the graph, you're going from this side, you're going down, then it turns around and comes back up. So what would you say? Minimum, does it have a minimum value or maximum value?
Minimum.
It's going to have a minimum value. Why? We've got a low point, don't we? It's definitely not going to have a maximum value because these ends here, they're going up. So there's not going to be a highest value because, you know, the function value is the y value. There's not going to be a largest y value for this one. But as was stated there, this one's going to have a minimum value, and more specifically, that minimum value is at the vertex. So it's going to have a minimum value, and the minimum is going to be at the vertex. Okay? And so not only could we say, yeah, it has a minimum value, but we can also then, what is the minimum value? Well, since it's at the vertex, we know something about finding that vertex, don't we? Where does the vertex occur? How do we find the vertex of such a function as that?
Negative b over 2a.
So use that vertex formula. Yeah, so the vertex formula tells me h equals negative b over 2a. And so negative, so we've got the a, here's the b is 8, so it'll be negative 8 over 2 times 2. So that's negative 8 over 4, which is negative 2. Gives me the h of the vertex, and the k of the vertex is, plug that in for x. So it'll be 2 times negative 2 squared plus 8 times negative 2 minus 7. And so if we can figure that value out, It's negative 15. The answer to the question here would be, all right, so here's, I've got the vertex now, it's negative 2, negative 15. And so which of those two is the actual minimum function value?
Negative 15.
The negative 15, yeah. So it's negative 15 here. What is the minimum value? It's the k of the vertex. So negative 15, what is the minimum function value? Negative 15 is the minimum function value. That's as low as it goes. It occurs at negative 2. The minimum value, though, minimum function value is negative 15.
Now, if it was the maximum value, would it be in that same spot?
All right, let's look at one. All right, so let's say we've got f of x equals, let's just do negative 0.25 x squared plus, let's go 10.2 x plus 17.86. Just making something up there, all right? All right, so maximum or minimum here? This one has a maximum. Why? Because this is a parabola, x squared, that opens down. Because a is negative 0.25, a is less than 0. And so, you don't really have to sketch it, but just kind of draw one there. It's going to look something like that, because it's a parabola that opens down. Wherever that parabola is, it's a parabola that opens down. And so, yeah, this point here is going to be a maximum point. And so what is the maximum value, then, of that function? Well, it's, again, at the vertex, right? Where's that vertex? Well, it's, again, using the vertex formula, h equals negative b over 2 times a. So in this case, it'd be negative 10.2 divided by
2 times negative 0.25.
2 times negative 0.25, negative 0.5.
I think it's negative 20.4.
Negative 20.4?
It's positive 24.
Positive 20.4. Yeah, you got a negative divided by negative, don't you?
Yep.
So it'd be a positive 20.4. And so then the k, plug that in, you got negative 0.25 times 20.4 squared plus 10.2 times 20.4 plus 17.86. Plug that in, see what we get. Lots of decimals. I get 121.9. Did you get it?
Yep.
So again, the maximum value is the 121.9, okay? The k value of the vertex, that'll be the maximum value, okay? All right, so now let's do sort of the same problem, but in the context of maybe of an application more so. All right, let's say a projectile is fired upward. And its height in feet after t seconds is h of t equals negative 16t squared plus 803t. Find its maximum height. Okay, so the idea is, of course, that you know, you got the being fired upwards, so what goes up must come down. So at some point it reaches the maximum height. Question is, what is the maximum height? Well, again, if we think about this function, I mean, we could plug in some different t values and try to come up with that way, but the better way is to think about where this maximum would occur, because think about the graph. It's a parabola, isn't it? And it's going to be opening downward. So the maximum is going to occur, again, at the vertex, okay? So maximum occurs at the vertex. This is an opening down parabola. A is negative, so it's going to be opening down. Occurs at the vertex. So this, again, is just finding the vertex again. The H is negative b over 2a, so that in this case would be, b is 803, so it would be negative 803 divided by 2 times a, so it would be negative 2 times negative 16, negative 32, yes. So it's 803 divided by 32.
25.09.
25.09?
Yeah, a few other numbers, but.
About 25.09, somewhere, give or take, right? So then the k, plug that in. In this case, for we got x instead of t, so that would be going in for t. So it's negative 16 times 25.09 squared plus 803 plus 25.09. I get, see what you get, I get 10,075. Anybody else get that?
0.4140.
Yep. All right, so that's our, right there. So that would be our maximum height. In this case, height's in feet, so that'd be a little over 10,000 feet. Now, the other question here is what does the h represent? Well, the h represents, like I said, we plug in the h for the time. And so wouldn't that h represent the time that it takes to get to the maximum height? It may ask that on these particular problems. So if it asks for the, well, how long does it take to get to that height? It'd be the h value here, because that's what we plug in for the time. So the 25.09 would be the seconds it would take to reach the maximum height. You wanted to interpret that, okay? So it takes it a little over 25 seconds to reach that maximum height, and then it starts coming back down. All right, one more of these. All right, the cost in millions, millions of dollars. To produce a product is C equals 0.3x squared minus 2.5x plus 8.4, where x is the number of units produced. All right, so yeah, you plug in, in thousand, I should say. So if you're producing 10,000 units, here you plug in x to be 10, because x is in thousands. And then the cost comes out in millions of dollars. So we've got some high dollar production here going on. All right, so A would be find the minimum cost.
It's the minimum because it opens up.
It opens up. Yeah, this is a parabola opening up, isn't it? We've got 0.3x squared, so that tells me it's a parabola, and A is positive. That's telling me this is an opening up parabola, and so this minimum cost, yeah, it's going to occur at the vertex. So we've got an opening up parabola, so the minimum cost is going to be, again, at the vertex. Which is vertex, we've got negative b over 2a for the h, so that'd be negative 0.25, positive 0.25, also known as, divided by 2 times 0.3, so that'd be 0.6, positive 2.5 divided by 0.6. And let's see, that's going to be
4.16 infinity.
4.16 infinitely, yeah. So let's just say that's 417. Should give us for my h. So then the k is 0.3. Plug that in for the x. 0.3 times 4.17 squared minus 2.5 times 4.17 plus 8.4 should give us accuracy there enough. I get what you get, but I get 3.19167. So
Same.
that what you get?
Yep.
3.19. Let's go to 2 here. They may tell us, I didn't say what accuracy to round it to, but it's about 3.192-ish, 3.19. And all right, so the question was, find the minimal cost. It's not 3.192, is it? Because the cost, we've got it in millions of dollars, so it'd be 3.192, yes, but 3.192 million dollars, yeah. Just to be totally accurate here. And then one more, let me give you, is that okay? Any questions on that? So the B part here, the other part I may ask, is how many units to keep costs at a minimum? How many units should be produced to keep costs at a minimum? Well, actually the answer to the question we've already got here. It's just a matter of interpretation, or interpreting what we've got. So the minimum cost we know is 3.192. So this is asking, well, how many units should be produced to give me that minimum cost? And the answer, of course, is the x value that gave me the minimum cost, which is what?
4.17.
It's the h value, yeah, 4.17 thousand. The h value. Okay? Question or concern? All good with that?